Hello friends, welcome. Today we are going to learn basic difference between the DFA and NDFA. I have already made the videos on these topics. So if you have not watched those videos, please watch them. And today we will learn the main difference between the DFA and NDFA with the examples. So first of all, you have to know what is the DFA, and I have already told you that the DFA may be represented with the 5 tuples. So you have to know these 5 tuples. On the basis of that 5 tuples, you will clearly understand that what is the basic DFA. So first of all, the first ever tuple here is Q, capital Q, then sigma, then delta, then Q naught, and then capital F. Here Q is representing Q is representing the set of all the states. So all the set of states are coming under this capital Q. Next is sigma. Sigma is representing the input alphabet. So whatever all the input alphabets and all the set of symbols are coming under this input alphabet, that is sigma. Then we have a delta transition function. We will know that Q on getting input sigma, it moves to the Q. Here means on getting input, on getting some input, the state will move or state will transition of the state from to the another state. Next here is the Q naught, which is representing the initial state. Whatever the initial state, it may be represented. Here we are representing it with the Q naught, and the F is representing all the set of the final states. So all the set of the final states are representing here with the capital F. So we will see the one example, and we will know these are some states. These are some states. Okay, this is the initial state. Initial state is representing by the incoming arc, which doesn't having any symbol. Okay, there is no symbol associated with this arc. So this is the initial one state. Okay, now if we are having Q naught on getting input 0, it moves to this Q1. Q naught on getting input 0, it moves to the Q1, and Q1 on getting input 0, suppose it goes to the Q2, and suppose that this Q2 is the final state, and we are representing this final state with the double circles. We have already known about it. So basically the Q naught on getting input 0, it goes to Q1, Q1 on getting input 0, we are going to Q2. Suppose we are having alphabet is equals to 0, 1. So we have to define each and every possible transition for these both symbols. So here I am representing only on getting input 0, Q naught will move to Q1. But about the Q1? What about the Q1? So if it getting input 1, suppose it on getting input 1, it goes to itself, and on getting input 1, Q1, it goes to the Q naught, and Q naught, Q2 on getting input 0 or 1, suppose it stays in itself. Okay, so we have to represent each and every transition for the states or for the input symbols in the case of the deterministic finite automation. So what about the non-deterministic finite automata, NDFA? But in the case of NDFA, you are also representing it with the 5 tuples. We have 5 tuples, and all the 5 tuples will behave same as the DFA, but only the difference between them is just of the sigma. It's of the delta. So we are having delta equals to Q cross sigma tends to 2 raised to power Q. It means on getting in same input, we are having one or more than one transitions. So only difference is here in this case. So this Q naught is representing the initial state. This F is representing all the set of the final states, and this capital Q is representing all the set of the states, and we are having sigma. Sigma is representing all the input alphabets. So only difference in the case of the transition function, which is represented with the delta. Okay, so how we can show it with the example? So consider that this is Q naught, which is initial state, this is Q1 intermediate state, and this is Q2, which is the final state, and Q naught, this is representing the initial state, because we are using here the incoming without incoming arc without any symbol. So Q naught on getting input 0, it goes to Q1, and Q1 on getting input 0, suppose it goes to Q2, and Q2 on getting input 0 and 1, it remains in itself. Okay. Now consider, we will learn that in the case, we have already learned that in the case of the DFA, we have to make transition for each and every input symbol, but in this way there is no need to mention each and every transition for each and every symbol. So here I am only placing the transitions for the Q0 on getting input 0. Here I am not representing any transition on getting input what will happen if the Q0 is getting input 1. So this is the main advantage of the NDFA. In this we have note to mention we have note to mention each and every transitions for the every states for every input symbols. So this DFA is, NDFA is much more better than this DFA, and the structure form in the NDFA, it is more simpler than the case of the DFA, because in the NDFA we have we need not to mention for each and every transitions for the input symbols, but in the case of DFA we have to mention each and every transition for the input symbols. So I hope friends the idea will be clear to you. Thank you friends. If you like my video, please like, share, subscribe my channel, and if you have any query you can ask in the comment section. Thank you.